know that you are waiting for long for my videos covering the topics, and I also love you a lot and want your support. So I decided to proceed with the next chapter of our AI and machine learning as per the request of my subscribers. Most of the people, they say before DSA they just want to know about the subject, so just begin about it. Today's topic is the starting of neural networks and Perceptrons. A beginner learning roadmap will be there where I will guide you what is that, what is neural networks, how from the neural networks ANN will be developed, how the neural network is analyzing the data, why we needed it, what are the mathematical approaches for that, and everything that will be covered in this chapter only. So just move forward with me smoothly, and any doubt you can chat GPT it or can ask with me because many people just chat GPT it. Okay, no problem, you can ask me in the comment section. So let's proceed. So अब ये न्यूरल नेटवर्क्स किस चीज से बना, क्यों साइंटिस्ट के दिमाग में ये आया कि हमें न्यूरल नेटवर्क जैसी कोई चीज को डेवलप करना चाहिए। जस्ट सपोज कभी हमने 10th क्लास में डेंड्रम वगैरह का न्यूरॉन्स पढ़े थे, तो हमारे टीचर ने हमें 10th क्लास में ऐसे एक डायग्राम बनाने को बोला था जिसमें हमने दिमाग की न्यूरॉन्स को डेवलप किया था। ठीक है, आई होप आपको याद होगा, ऐसी हमने न्यूरॉन्स बनाई थी। द ड्राइंग इज नॉट दैट गुड एट दैट टाइम। ठीक है, और ये हमारा यहाँ पर उसने बोला था कि ये होती है डेंड्रम्स। ठीक है, ये होती है एक्सिस एंड ये कनेक्टेड टू द अदर न्यूरल नेटवर्क्स। सो बेसिकली ये करता क्या था, ब्रेन कैसे सिग्नल पहुंचाता है कि मेरे हाथ पे खुजली हो रही है, आई वांट टू खुजली करनी है मुझे अपने हाथ पे। तो जो डेंड्रम्स होते हैं ये क्या करते हैं, सिग्नल्स को, हमारे जो ब्रेन में सिग्नल्स आते हैं वो डेंड्रम्स के पास आते हैं। ये जो नसें होती हैं वो सिग्नल्स को कैचअप करती है डेंड्रम से। देन वो जो सिग्नल्स होते हैं वो एक्सन के थ्रू, जो पाइप होती है उसके थ्रू हमारा जो बैकएंड के डिफरेंट डिफरेंट और न्यूरल्स होती है उसकी तरफ जाती है और एक्शन में उसकी प्रोसेसिंग होती है। मान लो अगर हमने डाटा रिसीव किया तो हमारा ब्रेन जो है उस पर प्रोसेसिंग करता है यहाँ पर, और जो भी आउटपुट होती है वो दूसरी न्यूरॉन को बेचता है और ऐसे न्यूरॉन्स कनेक्ट होती रहती है और हमारे हाथ को पता लग जाता है समथिंग इज गोइंग रॉन्ग एंड आई हैव टू डू अ पर्टिकुलर थिंग। ठीक है, ये तो हमारा बायोलॉजिकल ब्रेन है, कैसे काम करता है। अब देखो, ब्रेन न्यूरॉन्स इज अ ब्लूप्रिंट फॉर आर्टिफिशियल न्यूरल नेटवर्क्स, अ सिग्निफिकेंट ट्रेवल फ्रॉम डेंड्रम सेल बॉडी देन एक्सॉन एंड देन नेक्स्ट न्यूरॉन। जो भी कहानी मैंने अभी बताई सिंपल भाषा में वही यहाँ पर लिखी हुई है। ईच न्यूरॉन्स फायर्स ओनली व्हेन इट्स थ्रेशोल्ड इज एक्ससीडेड, व्हेन द डेटा इज कमिंग टू द न्यूरॉन and the threshold of that neuron got exceeded from its limit, then it is passed to the axon and it's passed to the next neuron. I think it's clear till now. Everything is clear, good, everything is listening or are having peace to mind. ठीक है, जो भी बोलती रहती हूँ मुझे खुद नहीं पता लगता। आर्टिफिशियल न्यूरल नेटवर्क्स, देन अब तो दिमाग की बात थी। दिस इज ऑल अबाउट आवर ह्यूमन ब्रेन, हाउ ह्यूमन ब्रेन इज प्रोसेसिंग रिसीविंग द डेटा or processing the data to the next neurons. But from this human brain system, how the artificial neural network is developed. So suppose we have a large number of data, and large number of data is sent to a machine learning model and it have to get a particular output. So for example, you have a machine learning model and you put up a small amount of data, you might get an output very early or very efficient output. But about a data which is very clumsy, which is very segregated in a big data form, is your one model capable for that? I think not. For a video data, for image data, it is not possible for a single model to process the data, to get out the output and to process the output to the other neural networks. For doing that, there are different type of network of the models that are getting up the data and are sending to the another neurons, other ANN models. Then the process or the program is simulating and the action is given as an output. So what is going to happen there? Different kind of input data is given to a machine learning models or the simulation neural networks of the models that are interconnected with each other. Input is processed to that. Then we have the output as per the program, as per the situation that we will discuss in the video. So inputs and multiple weights term pass through an activity function to pursue the output and then output is given to us. अब यहाँ पर हमारा क्वेश्चन आना चाहिए, inputs तो we know that what is input, but what is the weight and weighted sum, and why weighted sum and bias is written over there. We will learn all about it in the next slide. So we are now going to begin with perception. Before perception, let's just talk about what are weights, what are bias, what are weighted sum in a very good manner. Okay, just give me a moment. Let me start or let me enable. Okay, cool. Just focus on it here only. So let me start over here only. What we are given with us that we have data. Suppose inputs are given, last data are there. Suppose there are many inputs given to a machine learning model or neural network models. For example, in image is there, camera image, photograph is there. There are many inputs, maybe in bytes, maybe in pixels of the photographs and everything. The inputs are given to us. Now, what we have to do, we have to pass it to a machine learning model and get out the output. Is it so easy? No, it's not so easy. First of all, we have to describe out of these inputs, which inputs have the maximum importance and why so. So, tell me in a simple way. Suppose you want to visit a restaurant, and you have to decide whether I want to go to a particular restaurant or I just don't want to go to the particular restaurant. So, what are the different criteria on which you will decide is first of all, distance. That not be the case that the restaurant is in Pakistan and I'm sitting in Delhi and I just want to be in Pakistan and eat some biryani. That's not possible for me at the time when I am hungry. Okay? Not in the time of vacations. Just consider the distance. Now, cost. Cost is also an input that we have to consider whether to make a decision that whether we have to go to Pakistan for a special meal or not. The third particular entity will might be anything like distance, cost, and beverage. For example, beverage, it may be sweet, it may be something else, or any particular input about restaurant. Cost is also a distance, and then what will be of restaurant. Yeah, for that, what we can take is think about it. Any good factor, distance, cost, and furnish you can say a distance, cost, and quality. Okay. Food quality is also a good reason for deciding whether I have to visit that restaurant or not. So you have given a restaurant. Now, on which factor you will decide the output? There are three factors: distance, cost, and availability. Now, your brain know, human brains know that the more focus I might given to distance. Okay. For deciding that whether I have to visit a restaurant or not, the major focus is on the distance. If a particular distance is less than or equals to 2 kilometers, it's fine for me to have a beverage over there. In case if the distance is greater than 2 kilometers, I might not go there by my automobile or anything. The second factor that I think that most important is the cost. I think the meal that I will consume must be less than equals to 200. Okay, or you can, this is a five-star hotel, then you can define the 2K. Okay, 2K bill. Then you can consider that 2K is okay. I can pay for a food, but apart from 2K, I am not able to pay for the food. So it's a final cutoff. Now the third factor is quality. What will be the quality of the food? I have to decide whether I have to go to the restaurant and the quality. If I'm a person, if you are a person who want to visit a restaurant, distance is the first important factor to decide. Second one is cost, and third is the quality. Sometimes we just compromise with the quality of the food just because of the cost or just because of the distance. So it's the third parameter to decide whether I have to go to the restaurant or not. So these parameters are given the priority in the term of weight. For example, if the weight is given as 0.9, the weight is given as 0.7, and the weight for this one given is 0.3. Now you can say the more priority is given to the distance, and then cost, and then quality. So you are given with the weights. Now you are given the inputs. Inputs are any number that you want to go, and you want to any number, then any data. Now you have to multiply these weights with these inputs to decide your sum, to decide the sum, and deciding what is will be the outcome. Either it will be 0 or it will be 1. Now how will you will say that? We will just multiply each input with each weight. Means we are given the input x1, suppose the distance is given there with us, or the input related to the distance or anything, or something input regarding the restaurant, the given data is given to us. Now we have to multiply with a, this case is x2 and w2 and x3 into weight 3. Now we have to sum up of all the things. Then the cumulative sum that is given to us will be our output. Now the sum will be, I hope, maybe lying between 1 to -1, or in the range of 0 to 1 as compared or as given about the weight. And how to define the weights? Our mind know that the distance is more important. Our mind know the cost is the second factor. But the machine doesn't know. How to train the machine, we will learn in the next chapter. No, next slide, sorry. So this range is given to as 1 and -1. Now how to decide from these weights and inputs that I know the distance is most important? I just multiplying these with mathematical approach and summing up. Now the final result that is coming up as a function, it might be 0 or it might be 1. So how I will know the output, that I might have to go to the restaurant or not? How the machine learning model knows that? Let's go. So perceptual definition. This is a simpler artificial neuron. It take multiple inputs, multiply each by a weight, add up the bias, computes a weighted sum, and pass it through a step activation function to produce an output. So if I will explain you in a simple way. So let's explain, or let's understand it. So we have given different inputs. I explained already. Now we have given the weights. What are we are given with the weights? We don't know which weight have the maximum priority. If we multiply it with the greatest weight, was moreover the it will be the greatest in all of them, and we just sum up all the results over there, and the function that will give us the sum of x1 y1 plus x2 w2 plus x3 and w3 will decide that whether we have to visit a restaurant or not. So in neural networks, when different type of inputs are given to us and we have to decide a particular one choice, then this function helps us a lot. Then it is also saying in the perception, and this all process of judging whether the input will be true or whether the output will be false is under the perception definition, when neural network is deciding the output on the behalf of input. In two classification or in the binary classification, this is the main logic. So it will give us the f function either 0, either 1, or if your weight is set it to a different range, will be covered in the next slides, then it will come to 1 in -1 range. Now a step function is there. Step function says if your output fx is greater than equals to 0, then the answer is 1. If it is less than 0, then answer is 0. This is our step function to decide our output. But it's saying that if I am getting 1 over there, then I must have to visit that restaurant. This restaurant is particular for me. If the answer is 0, that's simply define that this restaurant is not mean for me. I'm not happy over there. I'm not contented, and I must have to consider another restaurant. This is the simple formula to deciding a particular output in neural networks. Okay. The slides also saying the same, that we have given the x values inputs, and we have the weight, and we just calculated the weight or sum over there. their weighted sum is 0.4 and 0.4 is less than 0. This means it will give us 1 and we have to proceed with the positive one. The threshold is 0 since 0.4 is greater than 0. Output is 1 and by default in all the neural networks of perception threshold is given as 0. Okay, means if the input is greater than equal to 0 then the answer will be 1, otherwise it will be 0 or minus 1. Now, why binary classification comes over there? Now, if I talk about perception, you have noticed that the output either will be true or either will be false, or you can say as 1 or you can say as 0. I may go to the restaurant or can skip the same restaurant. So, is this a pattern of binary classification? What does binary classification says? Binary classification says that the technology to separate all the groups into two groups. For example, in all the chunks of emails, we have to see which ones are spam and which are not spam. So you are just dividing those total 100 emails into group of spam and not spam category. So similarly, I'm doing same into my perception that I'm just checking out all the inputs, calculating it with the weights and summing over there and just calculating a function and deciding whether I have to put up that decision into going to a particular restaurant, not a restaurant, or going to a particular restaurant will be beneficial for me. So classification is going on. That is the binary classification in perception. Separated data into exactly two categories. Perception finds a straight decision boundary that divides the two classes. Classic example spam versus not spam. Now, how it's in perception, two output 0 or 1, decision boundary, separate classes, point on each side. One class will say as 1 and another class will definitely say as 0. Now moving further, binary perception. Wait for a while. Now we have defined that fx is given as the summation of xi and wi. Now we are coming up with the bias. Why I am using bias in it? Computer is weighted sum, then passes through a step function, checking a weights control feature important by shift the decision boundary. See, in linear regression or linear line, we are given up with the slope mx plus c. C is a bias. Why it is saying if my model is working something, I have to predict the accuracy of model by the actual outcome, by the calculated outcomes. Now, for calculating the actual outcome, we have to make up the classification or a line between them. For making a line or for making a proper mathematical equation for giving us the actual input, we are just adding up a bias that tends the data to be error, to decrease the error into the data and to put up the points on the line. So bias is just a mathematical approach to add up into our data to make our accuracy more. Now perception training intuitive. Now you can see key I have inputs x1, x2, x3. Now weight w1, w2, w3. Training a perception follows simple iterative cycle. This is just a cycle that you will just guess weights, then make up the decision means fx. Now if fx is given to 0, then you just make up some changes in W and then repeat it. Now guess that whether the answer is correct, then proceeding with the answer and moving further. Okay, but if in the input it is not given to us what is the value of our weight, how we are going to decide the value of our weights? So it's simple that you have to guess it. Okay, you have to guess it and make the model finite or you can say correct. Make the model correct. So just we can do is take any value of the weights as given in the question. If it is giving us the correct output that yes, visit the restaurant with different priority to distance, cost and quality. Like suppose for now, cost is the first priority, then distance, and then quality. Then the output is giving not go to the restaurant. Then my brain think, leave the cost factor, just decide the distance. I'm just curious about the distance is more important, and go to the restaurant. And might I will proceed to the restaurant by thinking the distance is less, no worry for the cost, I will save my time, just go with that restaurant. So just I have to improve my accuracy and then check about different values of w, and then go to the output. So just you can compute is y actual. Y actual means the formula with the bias you will calculate it in with y jo output, the output that was given our model. This will be our error with will be strength of our model. Then we will just compare the y n is equals to current w plus this one. It will say, it will now give us the new weight. We will put the new weight into our model and then check the accuracy till when the answer is not good to us. So w new is equals to wo plus mu and the error then the input x. Okay. Okay, y is equals to w means there is no error, means the actual jo theoretical y that we have calculated is just equals to the y, then error is 0. We can't, we is no, there is no need to update the w, so keep that weight same, and the decision in the final decision, no need to make more experiments or the input, just proceed with the decision and go forward. What is that? This is learning rate, step size, how much learning rate is of a model, then true label y, and then predictor label. This is just an example. A single mistaken prediction trigger a weight update. Then you have w, then multiplying it, getting a value, then old value, new value, just putting up the theoretical concept over there. Correction versus wrong. Why we are just focusing on the correction of w? If we not get making correction into a model, it is going with the wrong update. A wrong output is shared to the new neuron, and that odd output or you wrong output is passed to the next neuron and move further, and our final decision will be completely wrong. Model will get more pressure, but the final output will be completely vague or not used. So correct prediction is equals to model stay the same, wrong prediction is equals to model learns and adjust. Okay, correct prediction means we are getting that our W actual and W calculated is equal. No need to change with the W. But if it is not the case, we have to update W and make the model correct over there by checking up the inputs, by adjusting it, and all the things. This method is called the Rosenblatt algorithm, where we are examining and are correcting over the things. Okay. Now coming above the multi-class classification. What is multi-class classification? Binary classification is that we have two classes, either true or either false. You are just putting up the data in true or false. What is multi-class classification? Suppose your model wants to know that I have a pet. Is that pet is a cat? Is a pet is a dog? Is that pet is a bird? How we will know? If it is binary classification, we just classify as true or false, that it's either cat, it's either not a cat or a dog. It will be pretty easy to do with the binary classification. But about the third parameter, if there are third parameter, now multi-classification help us to check about the classification of our model or to predict the output. One boundary and classes need n score function. Each class gets its own weight. One binary prediction can only separate two classes with a single line. For multi-classes, dog, cat, bird, we can multiple classes. How we are just going to decide our model now. As perception in binary, there will be two cases. How it's in that case. So each class has its score from its own prescription. The model picks the class with the highest score. This is agreement's operation. Prediction is equals to maximum score. So what it is going to say that for each cat score, what is going for cat, only cat, it is going to check the perception value, means the fx function output, then it's getting up the fx. It will calculate the value for cat with all the different classification, then it will check for the dog, and with all the classification, then it will check for the bird, and final output and look for the maximum value. Now the maximum value is coming up in the dog, means dog is my pet, not the bird and the cat. So same here. Scores adjusted after each prediction. The correct class score increase while the wrong prediction class score decreases. ठीक है? This is also simple way. One versus rest versus multi-classes means we are just comparing cat value, cat input with dog and bird, means all the classes we are calculating it. If we are going to calculate with dog, we are comparing dog with cat and bird, or the rest one. Rest trains one binary perception per class, each asking is this class or not. The multi-class perception assigns a score per class and picks the highest. Means for each one we are picking up a cat and comparing with the others, then calculating the scores and checking is this the class that are most important to us or not. Now common mistakes. Concept to remember, avoid this pitfall when learning perception. Each concept below is essential. Data is not linearly separable. A single perception will never converge. Means if your data is not able to put it in the classification, then it's hard to give up one output or one perception over there. Key terms that you have to be remember about the weights, bias, threshold, learning rate, prediction, error, update, and linear separable that I already have. And the vision sheet, these are all the formulas that we have. Listen, perception, how to calculate it. Update value means how to calculate the W's. Then flow inputs, then we have weight, input, multiply it, then sum, then activation means the following up all the theoretical concepts, and then getting up the output. So it was the simple explanation of the few topics of neural networks, on the introduction of neural networks, perception, how neural networks is defining up the inputs and processing it and giving up an output to us. I hope you have understand it. If you want me to cover the rest of the series in Hindi, just comment me out over there and reach me out for any other help. I hope you have understand it. If not, let's proceed with the chat, open chat, and then tell me for practical session in the next lectures, and we will proceed with the topics. The one mistake that I have noticed that I am putting up a bundle of data in small videos and was not covering the practicals in data science and machine learning because of the time shortage, as I was busy in my placements and everything selection. And I really glad to announce that I got placed in a good company, USA based company. I will share the details with you soon if you want to know or you're interested in it. So till then, keep learning, keep growing, and be in the pace of chasing something. Meet you in another session of neural networks. Bye bye.